Today I'm going to discuss the periodic table of elements, atoms, and ionic bonds. When we look at the periodic table of elements, remembering that matter is anything that has mass and takes up space, elements are the stuff of matter. There are different kinds of elements, and these elements have constituents called atoms. Not every atom within an element is identical. When we look at the different elements like hydrogen, boron, carbon, nitrogen, oxygen, fluorine, neon, all of these different elements have a number assigned above them, which is the atomic number. The atomic number indicates the number of protons within the nucleus of the atoms within that element. However, the atoms are not identical, and that is because the atoms, even though all hydrogen atoms have one proton within their nucleus, they can have varying numbers of neutrons. Remember, protons have a positive charge. Neutrons don't have a charge. They're considered electrically neutral. So if we were to look at a sample of the element hydrogen, we would see that every single hydrogen atom has one proton. However, some of those hydrogen atoms will have one neutron to go with their one proton. If we look at a sample of hydrogen atoms, we'll find that if we look at the atomic mass, which is the average of protons and neutrons together, that the mass is 1.008. So there are some hydrogen atoms that have one proton and two neutrons, and those would be considered isotopes of hydrogen. Atoms with varying numbers of neutrons are isotopes. Normally when we look at interactions, because we're dealing with protons and electrons, we don't consider the neutrons very often until we get to radioactive isotopes. That's going above and beyond what we're discussing for our course. When we look at the atoms that make up the elements, the atomic number is going to be important because prior to an interaction between atoms where they might become attracted to one another, the number of protons always equals the number of electrons, or you could say the number of electrons is always going to be equal to the number of protons. I'm going to switch over to the whiteboard, and I've already drawn out some atoms for you. I've drawn out sodium and chlorine. Sodium has an atomic number of 11. Therefore, we know we have 11 positive protons. We know the number of electrons is always equal to the number of protons prior to sodium getting close enough that it could potentially interact with another atom. Over here, I've drawn out chlorine. Chlorine has 17 protons. Therefore, there are 17 electrons because the number of electrons are always going to be equal to the number of protons prior to any interaction. When we look at sodium with its positive 11 protons and negative 11 electrons, remembering that electrons are the subatomic particles that are going to orbit the nucleus at different energy levels, right? And it's a three-dimensional structure, so those electrons are orbiting the nucleus in a three-dimensional kind of spherical shell. We know that according to the octet rule, the first energy shell orbiting the nucleus can only hold 2 electrons. With 11, we can fill this first orbit, this first energy shell, with 2 electrons. The next 8 electrons are going to orbit the nucleus in the second energy shell. 2 plus 8 is 10. We've got 11 electrons, so that means that our third energy shell is going to be where that last electron is going to have to orbit, because the first can only hold 2, the second can only hold 8. So this third electron is orbiting in a shell all by itself. The outermost energy shell of any atom is referred to as the valence shell. I learned years ago that valence shells, or the outermost energy shell, likes to either be completely full or completely empty. When we look at chlorine, chlorine has 17 protons, therefore it has 17 electrons prior to forming any kind of interaction. So the first energy shell can only hold 2 electrons according to the octet rule. The second energy shell can hold up to 8 electrons. So we know we've got 2 electrons in the first shell, 8 in the second. 2 plus 8 is 10. Well, we've got 17 electrons, so if we take 17 minus the 10 that we've already put in the first 2 shells, that leaves us with 7 remaining electrons. 1, 2, 3, 4, 5, 6, 7 remaining electrons in the valence shell, the outermost energy shell. If sodium and chlorine were far apart from each other and far apart from any other atoms, they would not have a way to interact with anything, and this is how they would remain. If sodium and chlorine are approximated where they can come close enough to interact, then what we see happening is this negative electron is going to want to jump ship and go over to chlorine so that it can take this spot. And that's actually what happens. This negative electron is going to vacate the valence shell from sodium to fill the valence shell of chlorine. Now, if we take negativity, right, because electrons are negative, if we take negativity and put it over on chlorine, that means that chlorine is going to have a net negative charge of 1 because it gained 1 negative electron. We know that if sodium loses this 1 negative electron, it will now have a net positive charge, that's a plus, of 1 because it's lost that negative electron. So I'm going to erase this guy because it's jumped ship. It's actually transferred all the way over to chlorine. Now the valence shell of sodium is completely empty for all intents and purposes. It technically no longer exists. The valence shell of chlorine, which has now become chloride with this 1 negative electron, you don't have to worry about naming these things, is now full. And now this atom has a net negative charge of 1. This atom has a net positive charge of 1. Remember, opposites attract, right? Like north and south poles attract, opposites attract. Whenever we have a negative and a positive, they're going to be attracted to one another. And it's a very strong attraction because we've actually lost an entire electron to this atom. So that's a very strong attraction. That's what forms an ionic bond. Remember that when atoms become ionized by gaining or losing electrons, atoms that become negatively charged ions are referred to as anions. Atoms that become positively charged ions are cations. And so the negatives are attracted to the positives are attracted to the negatives. That's what forms our ionic bond. So, sodium chloride, table salt, is held together by an attraction between the positively charged sodium atoms and the negatively charged chlorine atoms. What happens when we put ions in water and ions that are attracted to one another by ionic bonds? Well, remember that water is a polar covalent molecule that has partial negative ends and partially charged positive ends. And the partial charges of water molecules will actually tug on the ionic bond, separating these atoms from one another, because the negatively charged oxygen ends of water will surround the positive sodium, and the partially positive charged hydrogen ends will surround the chlorine. And that's how salt dissociates. To dissociate means to break apart, to be pulled apart. So the bond is broken by the pulling apart by these partially charged atoms within water molecules. And you know that salt dissolves in water, right? Now, sometimes you might see an atom written like calcium is here with 2 positive charges. Well, what does that mean? That means that that calcium atom got rid of 2 electrons from its valence shell. So it's got a double positive charge. And if you notice down here, I've written helium out. I'm going to go back to the periodic table of elements to show you that helium, neon, argon, helium has an atomic number of 2, neon has an atomic number of 10. Well, helium, our nucleus has 2 protons, right? Let's pick this up. There we go. 2 protons. Therefore, it has 2 electrons. Now, if we look at this valence shell, the outermost valence shell, there's only one, is completely full. Therefore, this is considered inert or unreactive. Unreactive atoms have completely full valence shells. They're not going to interact with anything. The only reason these guys interact with one another, even though their valence shells are now happy, is because of the charges associated with these atoms by the loss and gain of electrons. This guy lost an electron, this guy gained an electron, so now they have a charge, and that charge, that polarity, is what attracts them to one another. Helium shows up to the game just like this, so there's no chance of any interaction with helium. If I draw out neon, neon had an atomic number of 10, right? So its first energy shell will have 2 electrons. There's 1, there's 2. Its second energy shell will hold 8. 1, 2, 3, 4, 5, 6, 7, 8, right? So we said it had 10 protons. If it's got 10 protons, it's got 10 electrons. First shell has 2 electrons. Second shell has 8. 2 plus 8 is 10, right? 8 in the second shell fills that second shell. Therefore, that is inert, unreactive. They show up to the game this way. They are unreactive, inert, noble gases. And that's true with all of the noble gases. They are considered inert or unreactive. I'm going to go ahead and leave this where we are, just to remind you that when we put salt, because ionic bonds form salts, sodium chloride in water, that bond, that ionic bond, will dissociate in water, and that causes these ions to become what we call electrolytes. Electrolytes are simply ions in water. Positively charged ions are cations, negatively charged ions are anions. The atomic number of an atom is always the number of protons. The atomic mass of an atom is always the number of protons plus neutrons. We don't count the number of electrons in atomic mass because those are like eyelashes. If you stepped on a scale and an eyelash fell off, it would not change the mass on the scale, the weight. And the same goes with the atoms. If we take away or lose atoms, it doesn't really change the atomic mass. We just look at the numbers of protons plus neutrons. I hope that helps in your studies, and I'm going to make another video on covalent bonds.